9. I'm reading with it. Thank you.
Good morning. How's everybody doing?
Good.
Good. Yeah, that. So, we have, interesting week ahead of us. Today, we're going to address some things from the Chapter 12 homework, and then, once everyone's comfortable with that assignment, move on to talking about the test and reviewing the test. Calendar up. So, Chapter 12 homework is due tonight, and I recommend making that your top priority. Just even though I open up the test for you to be able to see it today, it does not mean you have to do it today. So, focus on the Chapter 12 homework and quiz. Make sure that you are able to complete them, understand everything in them, send me questions. We'll also spend time today talking about them. There's some things specifically I want to draw everyone's attention. The first test, it should now be available for you to see, but again, focus on the 21st. That said, it's going to run until Friday at midnight, so that everyone can take advantage of the fact we're going lab this week. No lab this week, use it to study or to take your assignment. And while taking the test, you will have access to basically the entire right space page, because the notes and formula sheets are here. There we go. This formula sheet is the official one for the class. It contains some things from last semester as well. It is very handy and has everything on it we possibly need. Some capacity. Since we have only done heat thermo stuff, you'll only need this first column of all the information here. That said, the constant tables with things like specific heats will be in the notes, and I will try to make those. Probably put up a second document within this new test tab that I've made that will just have those constant tables in them. Just the ones from the notes again, because those will be the only ones that show up. Or you can, I'll make sure you have all the constants that you need, as long as you come here and check for that document when I upload it. Good morning. Speaking of this test tab, it's still under construction, but when you look on test 1 itself, it reminds you what chapters we have covered that we're dealing with for assessment. I'm going to list all the individual topics here. I'm going to go through those today. And I am in the habit for all my classes of giving practice tests, which is just to say a list of study questions that you can do ahead beforehand. That'll be the same types of stuff you would see when you test itself. These are completely optional because it's just more work. You don't have to do it. But if you want new practice questions instead of just looking at the ones you've already done, these are here. And so is an answer sheet, so you can check your work right then and there. I apologize a little bit. I kind of dropped the ball last week. I try to normally give these tests out, like the practice tests, a week in advance. And I just completely dropped the ball on that, and I do apologize. So that's another reason why I'm extending the test to take up the entirety of the week. So this is here, it's a good resource, and our other classes for this week will be focused mainly on test studying and any questions you have while working these. If you feel you are completely prepped for the test, or you finish it soon and then you don't want to come to class the rest of the days this week, I understand. I don't take attendance because it's up to students whether they come or not. This week in particular, since it's just test week, I'm just trusting you guys to get everything done and to let me know when you have questions, either by coming to these or by emailing me. So this week specifically, class is review. Next week, though, we will be starting on the next set of chapters. So next week is resuming as normal, with the lab and learning. But this week, attendance is optional. No lab this week at all. So just to visualize that real quick. So no lab this week. First week of March, though, we are back in lab. Test is open calculator, open formula sheet, and open any questions you have for me. Do please email me. Part of the reason the timer is being set to 5 hours is so that you can get your question answered. Just keep your questions to working hours, because if I'm asleep, if you're sending me emails at midnight, I'm not going to be able to get to you quickly. Just keep that in mind. Now, keep an eye on this. I'll be adding more information to it.
Oh, really quick.
Yes.
On website, is this set up for the test like you set up for the quiz, or is it set up for the test like you submit an answer and you can't change it? Or is it, how does that work?
It'll be more like the quiz. You won't necessarily know that the number you submit is correct. And once it's done, unlike the quiz, it won't tell you a grade. Because normally on quizzes, it's already frustrating enough that it will give you a 0 for a question, even if you've got to put in an answer that I, as a human, would say is correct. On this test, it's programmed not to give you a grade at all, because I'm going to manually set it and just tell you. I tend to, when you email me your work, I will reply on the same email what your score is and a breakdown for each question. So that's why it is imperative to send me your work. The higher the resolution, the better. The better the images, the better. But you can just take pictures with your cell phone and email them to me as long as they are legible. And try to label what question each piece of work is for. The easier it is for me to tell, the better the grading will be, the quicker you'll get your score. Yes?
Also, chapter 12, homework and quizzes to the night before.
Correct.
Okay.
Do prioritize that.
Okay.
Test opens today, doesn't mean you have to start today. So yes, the 12 assignments are due today, and I want to spend at least a little bit of time looking at those, because I've got some questions from students over the weekend that I want to address with everyone. Why did it go away? So I want us to spend some time on this shortly. Before that, does anyone have any other questions at all about, well, start of the day type of questions, or about the test?
I have like a question. Let's click on the quiz. So I don't, yeah, what do you want? I mean, I already took it,
Oh, okay.
but I just,
We can talk about concepts, I just can't say specifically what happened in a question. We can email afterwards, or just talk right after class if you want. At least for the homework, though. There are a couple of questions on the actual assignment that proved to be more problematic than I realized at an initial glance. And for that, I apologize to all of you. A couple parts of a couple of questions involve some either math techniques or logical leaps that in retrospect weren't really fair, because we, A, never talked about them, and B, you would never need them again. like, this would be the one time a question like this would come up because it happens to be snuck into a multi-parter. And that hardly seemed fair. Now, unfortunately, once I've posted an assignment, I can't edit the questions in that assignment. If I hadn't posted it yet, I could edit the question to remove a part of it. But since it had been posted, people have been working on it, I couldn't do that. What I could do is I could take the individual sections, like say a part C of number 1, and make them worth 0 points. So that's what I've done. Number 1C specifically is asked in a very strange way, and exactly what information they want is not super clear. And so I have made this specific part of the question worth 0 points. Even if you put in an answer and get it wrong, it will still put an X there, but you won't be penalized for it. You can also leave it blank and never submit an answer for it, and you will never be penalized for it. Yes.
Is this your chapter 12?
Yes, this is the 12 homework. And yeah, see, here's the point breakdown. It's what happened. And I know I did this at least one more time. Yes, so 6B is also worth 0 points because it doesn't actually give you, it gives a different gas for everybody in this particular question, which is fine until you get to part B, where it does not give you the information needed to figure out the molar mass of whatever gas you get is not contained in this question, which I already don't like. But then 2, it doesn't give you the specific heat for that gas at that temperature either. So because all the information is just buried and not in any tables that I ever gave you, I have made part B of 6 also worth 0 points. And it requires you to dig up information that you would otherwise not need except for this one time. Yes?
Is that the same, like, because I had to like look in the book for this, and it talked about like monatomic and diatomic, and then like the specific heat, and then it had like a fraction multiplied by R. Is that like what?
Yeah, that's all just for this question. Like if you read the book, there are some sections of the book that talk about it, but we did not go over it in lecture because for as long as I've been teaching this class, I've never put that type of question on the test, and it wound up sneaking its way into one of the homework questions, but I didn't realize. So I won't be asking questions involving molar mass or things like that. I know that comes a lot from not in chemistry, but I'm not a chemist, so I like to ignore it. So these specific questions that we've already said are worth 0 points are 1C and 6B. I think those are the 2 that I did. Okay, yes. Those are the 2 that I have taken out because I went there. So keep those in mind if you haven't done them yet and then start on them and they are frustrating, you don't have to do it. Let's see. Other, yes.
I know I emailed you about this, but I just, I know more.
You are allowed to ask questions, that is my job to answer them.
4B, okay, I understand that 4A is negative, yeah, I get that. And I did it is because work is done on the gas, from the gas's perspective, right?
Okay.
That's where I'm like,
Okay. Let's start at the beginning of 4. We have a cylinder containing the gas. You know, size of the piston, moles of gas inside, etc. The gas's temperature is going to rise as its temperature rises, and if we assume constant pressure, the gas is going to expand. Warm things up, they will get bigger as long as pressure stays constant. This means that as it expands, it should do work out of itself. So from the gas's perspective, it will do work. So if we were looking at things just from the perspective of the gas, we'd get a positive answer for the work being done by the gas on something else. But Webdesign asks for the work done on the gas. So we're reversing the perspective. The physical situation is the same. The piston is still going to expand, but we're just swapping the perspectives now. So we're looking at this from the environment's perspective. And the environment is being worked on by the gas. So technically speaking, from the environment's perspective, it's doing negative work on the gas because the gas is doing work on it. Work is being done upon the environment, so that amount of work from the environment's perspective would be negative.
So the gas did work.
Correct.
The gas did work, but A is asking about the environment's perspective, which means that it's negative because the environment didn't do work.
Work was done on the
And
environment.
then B, because gas is doing work, it's positive work.
Yes. The gas is doing positive work on its surroundings from the gas's perspective. From the environment's perspective, it's being worked on by the gas, which means it is gaining energy from the gas. And I don't much. Yes, the signs and the way that the physics is describing it can get strange at times, but when work is done upon something, negative number. Okay. Yes.
And then, okay, so why can work be like translated into like kinetic energy formula and potential energy formula?
Work is the act of using energy or transferring energy, and in either of those two methods, the energy can change its state. So when I lift something, chemical energy in my arm is being transformed into GBE. Alternatively, if I threw it, it would be turned into KE. So work can equal any other form of energy if the work in question is turning energy into that state. Or conversely, work can take energy from that state and turn it into something else.
Okay, and then just real quickly about 4A again, for the formula used. what, I know like work equals, B delta V. Like that's just like the formula. But for here, you weren't given V.
We're gonna have to go back to chapter 10 for this one. We have two states in this problem. The before state, where we are at this temperature, and the after state, where we are at this temperature. Things that remain constant throughout that whole process are moles of gas, yes. And I'm going to go ahead and tell you that pressure will also stay constant, because the gas to expand, for it to expand at a constant rate, I'm going to inform you to make that assumption. And so for this situation, we have of the two states, PV equals nRT for the cold state, PV equals nRT for the hot state. And then we could use that to solve for the volume of either one. But do you remember how we broke this back down into a bunch of smaller formulas? For example, comparing just pressure and volume in different parts of the system, or how just changing the temperature can affect something. If we were to hold R, N, and P constant, then that would tell us V1 over T1 should be equal to V2 over T2.
So you use that.
Well, that doesn't tell us delta V. I would still use the original to solve for V for both sets. Because in order to find work done, we're going to need this problem is a trick, more problematic than I realized. Okay, it says keeps gas pressure constant, so whatever it is. Okay.
Oh, so that you can just put in R delta T for, oh, okay.
Yes. Work equals constant pressure times changing volume. Pressure times changing volume will also equal nR delta T in this specific situation, since we know uniquely P and N are being held constant, which means we can shortcut work equals nR delta T. Saves us the step of having to convert to Kelvin as well. was just checking what version of R to use for this one, if it wasn't immediately clear. You're going to want to use the 8.317 for this question.
The 0.0806 or something like that one's for what?
That one's for liters and atmospheres, I think. And this is for pascals and meters cubed.
Oh, and we're giving centimeters.
We are given the
Sure.
surface area, although ultimately this method doesn't utilize it.
But isn't that the only thing that lets you know to use that R? Because or else I would have just been like, oh, let me use the R. Because I'm not giving like units of pressure because it's constant.
Correct.
Okay.
Well, the other hint is work equals P delta V, and to make that work, we need to plug in pascals and meters cubed. So normally, for just this by itself, without the little times 101.25 on the end, these would need to be pascals and meters cubed to actually create work. Which means we would need to use that version of R. Of the two, that's this one.
Did you say meters cubed?
Yes.
Meters cubed.
Pascals and meters cubed create 1 joule. This one is also tricky.
You know how to say this, like, when will the test be posted?
It's up now, but you don't have to do it till midnight, by midnight Friday. You have all week. There is no lag.
And we just send out a list to you within this 5 hours, right?
Yes. I'll reply to that email.
Yes, sir.
WebAssign won't tell you anything because it's going to be wrong, and I don't want you guys to be scared. I got this up. Number 12, I don't think is very tricky, but it does require you to dig up knowledge of friction.
Oh, okay.
Yes.
Sorry. 2, right? Why can you really work in Q?
In this situation, so pretty much any time one thing slides across any other thing on Earth, friction is going to be there. And friction, by its very nature, when friction does work, it takes usually kinetic energy away from whatever it's working on and turns it into thermal energy, just directly. You're not Pascal, you're not like $200. Evidenced by the fact one can hold your hands up like this. And why all machines overheat, because the gears are just touching and doing their jobs. So in this specific situation, we have skier on skis on flat ground. We know the coefficient of friction between the skis and the snow. And our goal here is to figure out how much thermal energy is needed to melt this much snow, and then how much work friction would have to do to create that amount of thermal energy, and then how far would you have to move to do that amount of work. So to put that little chain of steps here, and to remind everyone, the force of friction is equal to normal force times coefficient of friction. So, refresher. The chain of events here is, as the skis slide across the ground, friction will do work, taking energy away from the skier, turning into thermal energy. That thermal energy will, we're going to assume, go directly into the snow and start to melt it. And the way the order of operations I would recommend, sort of working backwards from amount of melted snow to the distance required. I would recommend, 1, solving for the thermal energy needed to melt that much snow. So we know mass of snow, and then latent heat of fusion of H2O, if I'm remembering correctly, is 3.3 times 10 to the 5th. Thank you. And we have the information needed to just simply find this amount of thermal energy required. We know how much energy is needed to do this. Once we have that amount of energy, that tells us the work that will need to be done by friction. Friction will have to do this much work. And work, the old version of the formula, is equal to force times displacement. But since this is the work of friction, we need the force of friction. That's our old friend. You all right?
I understand now.
Do you understand?
Yes.
Okay, good.
I don't like that it reaches back to us.
It is all connected.
Yeah.
I remember as a student here, I think it was my 3rd or 4th year of the physics major, I was taking electricity and magnetism, the special topics physics class, which was less about circuits and magnets as it was about calculating the Gaussian magnetic field as it passes through solid objects, which is less fun than it sounds. But after beating my head against that wall repeatedly, suddenly that combined with my heat and thermal class and my optics class and my basics physics classes in a very weird way. Suddenly all of it felt connected in my head for the first time. All of this connects somehow. This will never not be relevant. As heartbreaking as that might be at times, but I will always remind you of the old formulas. I'm never going to hide them from you. So, heat required to melt ice. That heat is going to be the work that friction has to do. We need to know the force of friction, and that will help us find the distance that we need to slide. So, back over here then, force of friction is normal force times mu. We're given mu, where do we pull this number from?
So like Y direction when you're drawing like arrows, like the force thing.
Yeah, good old force body diagrams. If this is our boxy skier, how do we determine the normal force? Assuming we are on flat, level, horizontal snow.
That's equal to mg.
Right. If you're on flat ground and not accelerating up or down, normal force should be one opposite of the force of gravity. So if I expand this just one more line, This is massive skier, different term to massive ice.
The key, yeah.
Or snow. Because if you were to combine these all into one line and just set m times L equals this, they're different masses, they don't cancel out.
Okay, I also want to ask about 8E.
80?
Yeah.
Sorry, double check. 8E.
Uh-huh.
Oh,
Wait, is it moved?
I know.
Oh.
I have it on 2 screens now so that I can look at them without
How do
jumping.
you
all
do
over.
that?
Hmm?
How do you do that? I get so confused when teachers pull stuff across.
How do I do which part?
Well, like, how do you see something on there and it's not on there?
Oh, whenever you connect a computer to a second monitor, you can either copy the display or you can extend it. So like a setup where you have more than one monitor, I basically am just treating this as different monitors connected to the one machine. This is now a second monitor. And I don't know how it figures out. It doesn't figure out which one's to the left and which one's to the right. You just pick which one's the main one, and it's on the left. So since the computer screen is the main one, I drag it to the right of the screen, it appears up there. Um, 8E. This one, this is edging in on health sciences, and I don't actually know what defines a repetition in health science. So I might not have a very good answer, which is to say I have no answer.
I just like, okay, we were asked to find the frequency, which, okay, it will flashback, but I mean, I can do it, right? So, and then, but I don't understand how that frequency is gonna determine E, like why? If he was actually able to do the repetition at that rate, like what?
I think it's saying his body won't be able to sustain it for that period of time.
What is the definition of a rep in terms of exercise?
Like,
How many times you do it?
like once, like one rep is like doing one thing one time.
Okay.
So if you have like 10 reps, it's like doing that certain thing 10 times.
Okay. The actually do repetitions at the rate of
So I think this question's like saying he can do it, but it's not likely that he would be able to do it for repetitions at that exact rate.
Like, cause he's not a robot, cause he gets tired like that?
How many times per minute? 15 times per, using these numbers, it comes out to 15 times per minute.
I don't know how it works. Is that assuming that he's 100% efficient? Is it based? That's probably why he can't do it 13 times, because he's not efficient.
Um,
So he's not
keep up that same amount,
You will just simply run out of energy.
Yeah.
Yeah, I don't like that part of the question either, now that I realize what it's asking. When building these assignments, there are certain ones that the book has automatically, and it likes to sneak in things that I apparently don't want to be there, but don't realize that they're there, because the textbook put them there.
And the key question, the key thing at the bottom. I think that's good.
Sorry?
At the bottom, it says the body is only about 25% efficient. Keep going.
Bodies.
I mean, I know that we're not 100% efficient, but like, how was I supposed to know what amount efficient relating to the rate? Was I supposed to look that up? You know what I mean?
And that's why. Those are no longer also working.
At least E, you can guess once and guess again.
Yeah. 'Cause-
Yes, but I really conceptually don't like grading you guys for things that I myself can't explain. And I hate that the book sneaks things in when I'm not watching. Sorry, guys. WebAssign has a mind of its own. Okay. But in an attempt to not just complain about our computer overlords, before we break for today, I want to at least one thing I like to do when helping students study for tests is remind them of the list of concepts that will be present on such an assignment. So very briefly, this is the list of things we talked about in chapters 10 to 12. We have temperature scales, understand and be able to convert between Fahrenheit and Celsius Kelvin, thermal expansion, table for which will be provided, gas law, Pivnert, and the formulas that we derive from it. That's all of chapter 10. Chapter 11 talked about specific heat, Q equals MC delta T. We apply that to the idea of calorimetry, put those together, because all of our calorimetry examples are specific heat examples. Then phase change. Thermal conductivity. Laws of thermodynamics. Work in heat engines as applied to the first law. That's the work equals P times WV equation. And then we looked at the heat engine graphs. And also on this particular assignment. And we talked about entropy, but there was no math about entropy, so there won't be any entropy math on the test either. And the last thing, efficiency. That was it. Yes.
So like, when we're taking our test, will we not be able to submit each question one at a time, like we kind of did a quiz, or like one more?
You can submit them in chunks, but it won't tell you if they are correct.
Okay.
I'm trying to make it simulate if you were doing an actual paper thing,
Okay.
not virus written world. Yes.
Well, like, let's say I'm like, okay, I'm done with number one, and then I submit that one chunk, right?
Mhm.
And then I'm like, oh my God, no, I messed up. Can I, once I already submitted, click it and like put a different answer?
Yes.
Okay.
Yes. And again, it's not going to tell you the score at the end because I'm going to set the points. And that's to avoid it also marking you down because it wasn't perfect the first time. So, wrap up 12 stuff tonight. Send me questions as you have them, please do. Be pondering and going over all of these. On average, on tests, I usually have about one question per concept. So,
You just say like 10 questions at the time.
yes, so it's basically just it'll be very similar to a homework assignment, but with the grading system on the test. Because the homework is designed to take you about an hour of straight work, and the test is going to take you about an hour of straight work. And do please, if you want, wow, I spelled that wrong. Send me questions as you study via email or come to lecture this week with questions. We can also talk about and go over together the sample questions I put up on Brightspace. Those are a resource if you want them, and I'm rambling at this point. You have a wonderful day. No labs this week, and you don't have to be here. Go study, go rest, go eat, go rest.